Hello and welcome to my student. Today's lecture is topic polymers. In this topic, we have see some examples of polymers. First example, polyurethane. Polyurethane, it is a ester of carbamic acid, so known as the carbamates. They having the general structures are the RNHCOH and OH is replaced by OR dash. Polyurethane, it is a linear polymer which is prepared by reacting an alcohol with the isocyanate. Polyurethane are prepared also by reacting diols with diisocyanate. It is a isocyanate and alcohols. They may be treated to get urethane or carbamate. Like this polyurethane can be prepared when diisocyanate treat A with diol, a polyurethane may be obtained. That is a diisocyanate. This is diisocyanate in presence of diol to get polymerized and hence to get the product is polyurethane. Right? It is firstly this urethane or carbamate can be prepared by using this method. That is isocyanate in presence of alcohol and what the product is urethane. Then this urethane to produce a diisocyanate and polymerize to form polyurethane. Now we have seen properties of this polyurethane. Polyurethane are more flexible and have a lower melting point is about 150 degrees centigrade than corresponding polyamides. Now it is well known polyurethane is known as spandex. They may be used for the preparing a corset, girdles for human and also used in active sports wear for men and women. Polyurethane foams are prepared by blowing the air in molten polymer. They may be used for upholstery material for sofa and bed. This is a flexible foam also known as it is a rigid foam also used in insulating laminates and insulation cover in the refrigerator. It is also used for the coating the furniture and rubber articles to their resistance and to abrasion. Now next polymers is a polycarbonate. The carbonate is an ester of carbonic acid having the prepared the reactions of phosgene gas, like this phosgene gas with equivalent of alcohol. So this is a reaction for phosgene gas with alcohol to get nucleophilic addition or substitution reactions. Cl replaced by O, Cl replaced by O. This is a formation. So this is n number of molecules of phosgene can treat with the bisphenol A, is bisphenol A, and to get the product as lexan. Then this lexan can be prepared by the action of this diphenyl carbamate in presence of this lexan can condense with this lexan with the diphenyl carbamate in presence of vacuum 200 to 300 degrees centigrade and to get the product as the lexan, polylexan. Now we have see properties. It is a lightweight, transparent polymer having a high impact strength and melting point. It is resist to number of chemicals except only bleach. For these properties, it is used in bike helmets. It is also used to safety goggles, bulletproof glass, and is transparent glass. Next polymers we have discussed are here phenol formaldehyde resin. Phenol formaldehyde reacts with each other in presence of the acid or base as a catalyst undergo polymerization to give a product whose nature depends on the catalyst used in the ratio of phenol and formaldehyde. The reaction takes place in these steps like this. In the first step, phenol reacts with formaldehyde and to mixture of ortho and para methylolphenol. Is ortho, this is a para methylolphenol. These compounds react more formaldehyde and to gives a dimethylphenol like this dimethyl, here's a trimethylphenol as like this. Next step, methylphenol then condense with another molecules of phenols. This is methylphenol can condense with another molecules of phenols. The resulting produce polymerize and to give a low molecular weight polymers. The product depends on the catalyst in presence of the acid. A linear polymers may be obtained that is called as a thermoplastic polymer will produce is called as a novolac resin. But this novolac resin contrary with a more formaldehyde in presence of a basic catalyst, they will result in cross-linked polymer. This is called as a bakelite polymer. It is used in making the toys and other molded articles. Now we have seen stereochemistry of this polymer. In branched polymers, the side chain can have different arrangement with respect to the polymer chain, but different in the spatial arrangement. The polymer shows stereoisomerism. Now, first terms we have seen tacticity. Tacticity, it is defined as the difference in spatial order of side chain on its polymer chain leading to stereoisomerism. This is called as tacticity. Next, it is a three stereoisomerism are possible. First one, isotactic, syndiotactic, and atactic. Isotactic polymer, it means the polymer in which all the side chain arranged on the same side of the polymeric backbone. This is called an isotactic polymer. In this, all side chain as like this, it is arranged on same side. Okay. This chain is the same side. This is called isotactic polymer. Syndiotactic polymers, it means the polymer in which the side chain are arranged alternately on either side of polymeric backbone. This is called as the syndiotactic polymers. This show is here. It is a side chain alternatively. It means hydrogen is below, hydrogen is here, hydrogen is right. Some of the mistake here, but hydrogen is below like this. It is a all the groups they will be arranged on the same side. Atactic polymer, it means the all side chains arranged randomly either side of the polymeric backbone. This is called as atactic polymer. In isotactic and syntactic polymer chains, they can be packed together better because of a regular arrangement of these side chains. Hence, it makes the polymer more crystalline, and therefore polymer becomes stronger, rigid, will have higher melting point. In atactic polymer, due to random arrangement of side chain, they cannot be packed closely, therefore it is more amorphous and hence lower melting point and these softer polymers we get. Now, next points we have discussed are here. Ziegler-Natta catalyst, control of polymerization. Ziegler-Natta catalyst was developed by the scientists 1953 by polymerizing alkene monomer. Many Ziegler-Natta catalysts are organoaluminum compound and titanium trichloride. They are active catalysts of an alkyl titanium compound formed by transfer of an ethyl group from a aluminium to titanium chloride. Firstly, alkene monomer coordinate with alkyl titanium compound and to form dipi complex. The insertion of titanium carbon bond to form cis bond, and this catalyst called as a coordination polymerization due to formation of coordinate bond. This catalytic polymerization is a stereospecific image. At moderate temperatures, isotactic polymer is formed and at lower temperature, the diotactic polymer will get the product. Now, this is a type of reactions are done in Ziegler-Natta catalyst. Firstly, this is a diethyl aluminum chloride can treat with titanium chloride. Then what happens? This is attached titanium. So this is called as Ziegler-Natta catalyst. So Ziegler-Natta catalyst can treat with the ethene molecule like a propene to get pi complex complex formation with titanium. Then what happens? It is the insertion step. These carbon and titanium bond will break and it attached to this methyl. This carbon-carbon double bond is break attached to titanium. Like so, product is CH2CH CH3, CH2 CH3 and CH3. Right. So this is the product. This is called as dipi complex. Then after formation of this product, the next number of alkene molecule can insert or put in this Ziegler-Natta catalyst. So repeat the same step and to the formation of this type of product. And then after we can stop the reaction or this is called the termination of this reaction by using the ROH, that is the alcohol. But the product is polymers replace the product is. So these reactions using catalyst is called as a coordination polymerization because they involve formation of coordinate bond between vacant orbitals of titanium and zirconium and pi electrons of alkene. But nowadays, instead of titanium complex, zirconium complex also used, which is soluble in reactor solvents and thus act as a homogeneous catalyst. Thank you.